Hey everybody, this is Miss Eisencraft with Unit 4, Lesson 1, Practice Problem Help. Okay, this comes from your book, Units 3 through 5 book, Algebra 1, pages 136 to 137, numbers 1 through 3. All right, so the relationship between the amount of time a car is parked in hours and the cost of parking in dollars can be described with a function. Okay, identify the independent variable and the dependent variable. So independent, they talked about it being the influencer or the input. Okay, so the influencer or the input, and the dependent would be like the resulting variable or the output. So if you think about that, the cost is going to result from how much time the car is actually parked. So when we think of the amount of time a car is parked, that is what's going to be used. Input, independent. Okay, nice that they both start with an I. That is what's going to be used to calculate the cost of the parking. So this is going to be the output, otherwise known as the dependent. I think in science you call it a resulting variable. Okay, so the independent variable, what are we measuring? We're measuring time. How are we measuring it? In hours. Okay, the dependent variable, the output, is the cost. That's what we're measuring, cost. And how are we measuring it? In dollars. All right. Oftentimes, if you get a little bit confused, an XY table helps. What are you plugging in? You're plugging in time, and out comes how much you owe. Independent, dependent, in, out. All right. Describe the function with a sentence of this form. Blank is a function of blank. So what we want to always remember is that the dependent variable is a function of the independent, and meaning that the function uses the independent to calculate the dependent. So just remember the dependent, so cost is a function of time. A function of time. So your independent or your input goes at the very end of that statement. All right, so suppose it costs $3 an hour to park with a maximum cost of $12. Okay, sketch a possible graph of the function. Be sure to label the axes. So the independent always goes across the x-axis. Okay, we are measuring time in hours. So since it's $3 per hour, let's just go count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we're measuring time in hours. And across the y-axis, the dependent variable is the cost in dollars. And before I label that, let's make sure that we can fit everything, because if we go by 1, we're only getting to $6. So the maximum cost of $12, we need to make sure our graph goes to $12. Let's make equal intervals. 2 is a nice number to count by. 2, 4, 6, 8, 10, 12. So we will have this scale go by 2s. Okay. So $3 an hour. So if you park for 0 hours, you pay $0. Okay, that's nice. 1 hour, $3. 2 hours would be 6. 3 would be 9. You know, you could make a T-chart, but it's pretty simple, so I don't think you need to. 4 is 12. And then if that pattern continued, it'd be 5 was 15, but they said there was a maximum cost of $12. So this is going to staircase up, and then after they're like, you know what? That's the most we're going to charge you. So then it levels off. Okay. All right, kind of fun. Okay. Then it says identify one point on the graph and explain its meaning in this situation. So let's just grab, let's say grab this one. Okay, that point right there is 2, 6. Okay, I like to put the arrows there. 2 hours, you are going to owe $6. If you park for 2 hours, you owe $6. All right. This was a huge review from 8th grade, but still good to go over it, especially with some of this new terminology. Next one, number 2. This is talking about if something is actually a function. Remember, in order for something to be considered a function, the input needs to have one unique output, only one output assigned to it. I'm going to go like this. This is, I think, the easiest way for me to look at it. Based on this information from the menu, is the price of a burger, so the price, a function of the number of patties? Okay. So this here, let's just look at the patties and let's not worry about anything else. According to the menu, this burger has 1 patty and it's $3.49. Okay, this one has 2 patties and it's $4.09. It doesn't have to follow a pattern necessarily to be a function, just every input can only have one unique output. Okay, this one also has 2 patties, but the price is $4.59. So therefore, this 2 has 2 different outputs, so no, not a function. All right, pretty easy. All right, now we're supposed to decide if these are true or false. The distance a person walks in kilometers is a function of time since the walk begins. And because we do this a lot in middle school, and tables are a real nice way to understand, relationships of 2 variables, I'm going to put it here. Let's put the input over here and output over here. Your distance is a function of time. So the distance is a function of time. It looks like we're measuring time in minutes. And this is minutes since the walk has begun. Okay, 5 minutes into the walk, 10 minutes into the walk. And distance, we are measuring in kilometers. All right, similar to miles, but different system of measurement. Okay, select all true statements. If they're not true, I'm going to briefly talk about it. Is distance the input? Nope, it's the output. Nope. Time of day is input. Well, time is input, but it's the minutes since the walk began. So you're not going to say at noon, put in a 12. You're going to actually say, how many minutes have I been walking? So time of day is input. This part, no. It's time since walk begins, not just time of day. 2 o'clock, you're not going to plug a 2 in. Time since the person starts walking is the input. Okay, now we're talking. Yes. Does T represent the input? Yes, T is minutes, time, yes. Does D represent the input? No, D is over here for distance. And so instead of X and Y, they use T and D. And they said that up there. Oh, D is the output. The input is not measured in any particular unit. False. Fake news. The input says right here, where is it? Here. The input is minutes. It says we're using minutes. So no. We are using minutes. It tells us that. Is the input measured in hours? Nope. Minutes. For each input, there are sometimes 2 outputs. So if you've been walking for 5 minutes, And this is the same walk. You can't say, hey, I've traveled, 0.02 kilometers. Hey, I've traveled 0.07. There's one unique distance for every time. Okay. Now, maybe 7 minutes in, you like stopped and rested, and you could have the same output here, but the number over here, this input cannot have two separate outputs. So for each input, there are sometimes two different outputs. False. It tells us it's a function. That can't be true. All right. Hope that helps, and I hope that's a good reminder from your middle school mathematics career.